Hello, welcome to Math Work with Miss Berk. Today we're going to be talking about factoring polynomials using the area model. But first, let's review algebra tiles from your last lesson. Here you see I have the trinomial x squared plus 5x plus 6. And in the last lesson, you learned about factoring out to see what value could give us x squared, how we could come up with these terms, and then where we would get the 6. So I've already shown it here. You can see the length of our algebra tile rectangle is x plus 2. And our width is x plus 3. And if we double distribute those two binomials, we will get x squared plus 5x plus 6. So what we're going to actually do is we're going to take these same values and we're going to transfer them into the area model. So I'm going to redraw that rectangle, and I'm going to plug in all the values that we just had as algebra tiles, but I'm going to write them numerically. We had x squared here, 3x here, 2x here, and 6 right here. And what I want you to see is when we're looking at this numerically, we can figure out what these two terms were by factoring out the greatest common factor from each row and from each column. So if I look here, my greatest common factor between 3 and 6 is a 3. And if you remember when we had the algebra tiles a second ago, that was what value was right there. Looking in this first column here, I have x squared and 2x. The value that they have in common, and remember this leading coefficient is actually a 1, so the greatest common factor that they have is x. Going out to the side, between x squared and 3x, the greatest common factor is x. And then finally here on this bottom row, between 2x and 6, our greatest common factor is 2. Once again, giving us those values of x squared plus 5x plus 6 for our simplified polynomial, and x plus 3 times x plus 2 for our length and width. And the way we got those values was by looking at the greatest common factor. But something else I also want to point out is that you can tell the way we found 5x was combining these two diagonal boxes. So that's going to come in very important when we're looking at the next problem. So I'm going to go ahead and write out the next problem, but first I'm going to set up the area model. It's just a 2x2 box. You should remember this from when you were multiplying polynomials. When we had our factors here, we would multiply in. Now we're going to put our product here and we're going to factor out. So the problem I'm going to give you now is a squared minus 3a minus 10. So we see we have some negatives. I know that first term goes in the first box, a squared, and if you think about those algebra tiles, that squared value is always what goes in the upper left. Then in the bottom, I'm going to put my constant, which was negative 10. And then here I need to do a little detective work. I need to figure out what two values needed to be here in order that their sum was a negative 3. But also remembering that when I multiply this factor times this factor, I'm going to get a negative 10. So we're going to ask ourselves, what number times what number is negative 10? But when I add those same two numbers, I get negative 3. And we can think about the factors of 10. Factors of 10 are 1, 2, 5, and 10. And I know that I'm going to have a negative somewhere because this product was negative. So one of these values needs to be a negative in order for us to get that 3. And I think you can tell pretty quickly that it's going to be the 2 and the 5. Since my 3 is negative, I'm going to need that 5 to be the negative value. So I can verify that 2 times negative 5 is negative 10, and 2 plus negative 5 is negative 3. So when I asked myself what two numbers multiply to negative 10, but add to negative 3, this is what we figured out. So we're going to take those two values and put them here. It doesn't matter which one goes where, the 2 here or here, the negative 5 here or here, but just remember that these are going to have an a associated with them. So 2a and negative 5a. Now, once again, we're going to ask ourselves, what happens when I look for a greatest common factor? Between 2a and negative 10, that greatest common factor is 2. Between a squared and negative 5a, I think it's pretty quick to see that it is a. Looking horizontally, a squared and 2a, the greatest common factor is a. And between negative 5a and negative 10, our greatest common factor is negative 5. So I can rewrite this as a plus 2 times a minus 5. And if we use double distribution, we can verify that that value works out to be a squared minus 3a minus 10. Let's try one more. I'm going to draw my area model. And I'm going to use x squared, I should write the full thing over here, x squared minus 4x plus 3. So that positive 3 goes here, my x squared goes here, first term in the first box, last term in the last box, and then I'm going to look for the values that satisfy my negative 4. So when I add them together, something plus something equals negative 4, and those same two terms multiplied will be positive 3. I like to start with the multiplication first. There's only a couple of ways for us to get a 3. 1 times 3 and negative 1 times negative 3. Since this is negative, I now know that my values need to be negative. So I'm going to take these numbers and plug them in over here. So I have a negative 1x and a negative 3x. So let's factor. Over here, I know the only way to get this is x times x. But I also know that it's the right answer because that's the greatest common factor between x squared and negative 3x. And also over here between x squared and negative 1x. Looking at this row, between negative 1 and 3, the greatest common factor is a 1. I'm not sure if it's negative or positive, but I'll figure that out in a second. And then on this side, between negative 3x and 3, the greatest common factor is 3. So I can check by saying, does 1 times 3 make 3? Yes. Oh, but 3 times x doesn't make negative x. So this must need to be negative. And x times 1 is not negative 1x, so that means this needs to be negative. And then I can verify one more time, negative 3 times negative 1 does indeed give me a positive 3. So my factors for this are x minus 1 and x minus 3. Just remember you're looking for the two values that multiply to give you the constant, and those same two values that add to give you your middle term, the coefficient of your middle term. And when you're using your area model, you want to make sure to factor out the greatest common factor.